Hey guys, so you asked me to go over a couple of the problems we did in class today, specifically the word problems. So let's look at the one about Kayla and her garden. It says that Kayla plants green beans in half her garden. She also plants tomatoes in her garden, but we don't know how many, so we think that's what we're solving for. She has 2/12 of the garden left to plant more vegetables. So what fraction of Kayla's garden has tomatoes? All right, well, if this is Kayla's garden and our models don't have to be to scale, what I mean is when I cut this model in half, if it's not a perfect half, that's okay, because this is really going to be more or less a tape diagram and not a fractional model. So I know that half of Kayla's garden is green beans. What's the other thing I know? I don't know the tomato number, but the other thing I know is the part that has nothing in it that hasn't been planted yet. And that part is 2/12. So I know that of the two pieces that are left, I know 2/12 of it is unplanted. It's just dirt. And again, the thing I still don't know is what fraction of that was tomatoes. And I'm going to use red to help me think of tomatoes, to remind myself that's what I'm solving for. I know that this tape diagram, this model, is supposed to equal one whole, her one whole garden. So I'm thinking, how am I going to figure out this mystery number? How can I figure out what that question mark stands for? What fraction of her garden was tomatoes? Well, if I know the other two pieces, I can take them away from the one whole in order to figure out the missing piece. So let's do that. But first, let's combine them to figure out what is this total? What is 1/2 plus 2/12, this amount that we need to take away? We're going to take away again what we know, which is 1/2 and 2/12. Okay, we need to make them like denominators. We can do that with the easiest common denominator. We would do 2 times 12 is 24. And then to change our numerators, we'd cross multiply. 12 times 1 is 12. 2 times 2 is 4. We would add those pieces together because that's what we were doing. We were adding. And we would get 16/24. So we know that 16/24 of the garden has already been spoken for. A chunk of that is green beans and a chunk of that is unplanted, ready to go dirt. So now we have to ask ourselves, well, how many 24ths are in a whole? That way we can figure out how many are missing. One whole is 24 24ths. So I'm now going to take my 24 24ths and I'm going to subtract 16 24ths. Well, I know that 24 minus 16 is 8. And my denominator is 24. So my answer is 8/24. Now, the only other thing I want to point out here is when we get an answer like 8/24, we want to see if we can take it up a notch and simplify. We can't always simplify, but when we can, we want to. You should always check by asking yourself, 8 and 24, is there a number I know that goes into both of those numbers? Well, if they're even numbers, you can always shrink it up by 2. So cutting 8 in half is 4, and cutting 24 in half is 12. So 4/12 would be an equivalent fraction. But then always ask yourself, can I go even further? Sure, we can cut both of these by 2 again. 4 in half is 2, 12 in half is 6. Can I go again? Well, yeah, of course you can. Let's cut it in 2 again. 2 goes into 2 one time, and 2 goes into 6 3 times. Can I simplify this any further? Nah. So 8/24 or 1/3, both of those would be the right answer for number 4. Really, any of these, 4/12, 2/6, 8/24, 1/3, they all mean the same thing. They're equivalent fractions and would be acceptable answers. The reason we need to know that 8/24 is the same as 1/3 is because if this was a multiple choice test, 8/24 might not be an option, but 1/3 might be on there. And we need to know that they mean the same thing. Take a second to look at this or pause the screen if you need to, and I'll clear my screen and we'll look at another problem.